In this video, we are going to graph exponential functions. So, a couple things about exponential functions. An exponential function will either have this shape, and as we can see, it'll go left and right forever, meaning the domain is all real numbers. And the range is the set of all positive real numbers. So this is for when it's in the form b to the x. So there's no shifts or anything like that. We can see that the graph is going to stay above the x-axis. That's why the range, how far up and down, it'll get closer and closer and closer to the x-axis, but never cross it, never touch it. That's why the range is positive real numbers. And it's going to go left and right forever, so that's the domain. So it could be going upward from left to right, or it could be coming downward from left to right. But either way, again, this graph is going to stay above the x-axis, so the range is going to start greater than 0, and the domain is going left and right forever, so the domain is all real numbers. There won't be an x-intercept because it will never touch that x-axis, right? It's going to get closer and closer but never touch it. And the y-intercept is going to be at 0, 1. So whether or not it's going up from left to right or coming down, the y-intercept is at 0, 1. And then it's going to have these 3 points. So negative 1, 1 over whatever that base number is, so whatever b is. 0, 1, we already talked about that, that's the y-intercept, and 1b, so again, that base number. So let's go ahead and graph it. So we have this function, f of x equals 3 to the x power. And I already know some of these points, right? So 0, 1, because that 1 is going to be our y-intercept. And 1b, so b here is 3. And then negative 1, 1 over b, so it's going to be 1 over 3. But again, if you're not comfortable memorizing those, you could always plug it in. So f of negative 1 would be 3 to the negative 1 power, and negative 1 takes the reciprocal. And that's why it becomes 1/3. Same with f of 0. 3 to the 0 power, anything to the 0 power is 1. That's why this will always be the y-intercept when it's in that form, f of x equals b to the x, because anything to the 0 power is going to be 1. And then, of course, f of 1, anything to the first power is itself. So that's why those 3 points are the way they are. Now with an exponential, because it's a curve, we're going to want to find more than just those 3 points. So I'm going to go ahead and plug in f of negative 2. So 3 to the negative 2 power. Again, that negative takes the reciprocal, makes the exponent positive now. And then we take 3 squared and get 1/9. And then lastly, f of 2. So 3 squared is 9. Now that I feel like I have enough points, I'm going to go ahead and plot them. Obviously with 1/9 we can't be super accurate, drawing by hand, but we can do our best to get it close to that x-axis. So negative 2, and then pretty close to the x-axis. Then 1, 1/3, so about 1/3 of the way up. Again, it's hard to be precise here. And then 0, 1, 1 positive 3, and then 2, 9. So we see it's going up pretty fast. And again, if I plugged in more and more negative numbers, the negative, so if I plugged in, let's just say, negative 4 for x. The negative is just going to keep taking the reciprocal. So the reciprocal would be 1 over 3, now to the positive 4. And 3 to the 4th power, is 81. So you can see we're just going to get bigger and bigger numbers in the denominator, but because it's in the denominator, it's going to make a teeny tiny number. It's going to be a fraction with a huge denominator makes a really small number. So no matter if I put in negative a million here, I'm going to get 1 over 3 to the millionth power. It's going to get super, super close to this x-axis, but it will never equal 0. It's just going to be tinier and tinier fractions. So when you draw this graph, I do not want to see it go below. I'm not getting super close here. I don't want to see it go below or touch that x-axis. It's going to get close to it, but it's not going to touch it. And there you go. Why don't you go ahead and try this next example. And keep in mind you're starting with a fraction, so when you take the reciprocal of 1/4 is going to be 4 over 1, or just 4. Alright, let's see how you did. So keep in mind on a test or something, these numbers won't be there. You just have to pick them. You pick the x, you plug in x, you evaluate to find y. Alright, so f of negative 2 means I'm taking 1/4 to the negative 2 power. The reciprocal of 1/4 is 4, and 4 squared is 16. So that's going to be off my graph. F of negative 1. So 1/4 to negative 1 power takes the reciprocal. Again, the reciprocal is 4 to the first power is just 4. F of 0. Anything to the 0 power is 1. Whoops, it's 1/4. So 1/4 to the 0 power is still 1. F of 1. Anything to the first power is itself. And f of 2. 1/4 squared. 1 times 1 is 1. 4 times 4 is 16. So again, getting close to that x-axis. So I'm going to go ahead and plot these. Negative 2, 16 is off my chart. Negative 1, 4. 0, 1. 1, 1/4. 2, 1/16. Again, super close. So this is going to go up super fast, but it's coming down from left to right. And again, do not cross that x-axis because you're never going to get below 0 there. Alright, so let's talk about the differences in these two graphs. So we had 3, which is a whole number, and the graph was going up from left to right. We had 1/4, which was a fraction, and it came down from left to right. And that's always going to be true. So if b is greater than 1, so a whole number, then it's going to go up from left to right. If b is greater than 0, but less than 1, so meaning a fraction, it's going to be coming down from left to right. So again, whole numbers going up, fractions are going to come down. And that's always going to be true. Alright, so these two examples didn't have any shifts. They were just straight here. It wasn't moving over to the right or down or up or left or anything like that. This was just the general form b to the x power. But there could be what we call shifts happening. So for example, this is h of x equals 2 to the x plus 3 power. So this whole piece here, x plus 3, is in the exponent. So this is going to move our graph somewhere. But let's talk about where. So I need to plug in values that are going to make sense for my graph. Okay. So if I plugged in, let's say, -3. So h of -3 equals 2 to the -3 plus 3 would be 2 to the 0 power, which is 1. So I chose that specifically because this was x plus 3. So I knew if I put a -3 here, it would add up to 0. Because that's a very important part of our graph, right? So there's 1 point. And now I'm going to go either side of that. So like -2, -1, -4, and maybe -5. Let's see what happens. So h of -1. 2 to the -1 power plus 3. We have to add those first. -1 plus 3 is 2. And 2 squared is 4. Alright. H of -2. So -2 plus 3 would be +1. And to the first power is 2. Then I'm going to plug in -4. So -4 plus 3 would be -1. And we already know a negative exponent takes the reciprocal. So I get 1/2. And lastly, h of -5 equals 2 to the -5 plus 3, which is 2 to the -2. So I take the reciprocal, and then I have to square it. So 1/4. Now let's plot some points. So I had -1, +4. And -2, +2. Whoops. Sorry, that was the wrong spot. -2, +2. And then -3, +1. -4.5. And -5.25. So what's happening here is we still have that same shape. Still not going to go below 0. But I don't see that point of 0, 1. So my graph has shifted to the left. And I know it's gone to the left 3 units because that y-intercept should be here at 0, 1. But at the height of 1, it's back 3 units. Do we notice anything about the equation here? X plus 3, it shifted left 3. So just like when we did the parabolas, if I had a function f of x equals a to the x plus h, or sorry, minus h squared plus k, that piece in there with the x value was always the opposite sign. So if it was x plus 3, that means it shifted left 3. Same idea here. If there's something up there with the x value, it's going to shift the opposite way of whatever sign that is. Plus 3 is going to go left 3. If it was minus 3, it would go right 3. It's going to go the opposite way of whatever sign that is. And it's going to go this many units. Alright. Why don't you try this next example? Actually, try the next two examples. This -1 is not in the exponent. It's 2 to the x power and then -1. So not in the exponent. Versus here, this is 3 to the -x plus 1 power. So again, this whole piece here is in the exponent. Go ahead and try these two examples and see how you do. Okay, so we're going to graph f of x equals 2 to the x power minus 1. So let's go ahead and just do -2, -1, 0, 1, and 2. Because there's no shifting up here with the exponent, so I'm going to go ahead and stick with these values and see what happens. F of -2, 2 to the -2 power minus 1. Okay, so I have to take the reciprocal, 2 to the 2 power minus 1, which 2 squared is 4, and 1/4 minus 1 is a -3/4. Right? You could get a common denominator there if you needed to. F of -1. We do 2 to the -1 minus 1. That is the reciprocal again, 1 over 2 to the first power will just be 1/2 minus 1. And 1/2 minus 1 is -1/2. F of 0. 2 to the 0 minus 1. Anything to the 0 degree is 1, or 0 power is 1, and 1 minus 1 will be 0. Wait, -3/4, -1/2, 0. Now f of 1 to the first power, is just 2, and 2 minus 1 is 1. And f of 2, so 2 squared minus 1. 2 squared is 4, and 4 minus 1 is 3. Now let's just go ahead and do one more, see what happens. No one says you have to stop there. F of 3. So 2 cubed minus 1. 2 cubed is 8, and 8 minus 1 is 7. Alright, let's go ahead and graph these. So I've got -2, -3/4, so about 3/4 of the way down. -1/2. 0, 0. 1, 1. 2, 3. And 3, 7. So the question is, how far down am I going to go here? Is it going to go past -1? Well, let's see. Let's try something in the other direction. Let's try -3. F of -3 would be 2 to the -3 minus 1. So I take the reciprocal of 2, I get 1/2, and the 3 becomes positive. 2 cubed is 8, and then I would get a -7/8 there. So again, I'm getting closer here, but not quite -1. So as we keep taking more and more negative x values, I would be taking the reciprocal here, and I would get a smaller and smaller fraction, which then I would subtract 1. So it's going to get closer and closer to -1, but it's never going to cross that -1. So it's going to get closer and closer and closer but never crossing -1. And then going up. So is there anything that you can see relationship-wise of what's happening with this graph? We thought the y-intercept would be here at 0, 1, but it's shifted down. So what do you think this value does? It shifts the whole graph down, however many units that is. So how do you know how far to stop? Like, where is that line that's going to get closer and closer to? Well, that all depends on this value. So this didn't have plus or minus anything after 3 to the x. So it's never going to cross the x-axis. So that has what we call an asymptote. You'll learn more about that in other classes. Asymptote at x equals 0. Sorry, y equals 0. Because it's never going to go lower than 0 for y values. Then same thing here. There's not anything plus or minus. So it's never going to go below that x-axis. So there's an asymptote at y equals 0 again. Same thing. Even though there was a shift, it shifted left because of this plus 3. There's nothing plus or minus that base with the exponent afterwards. So there's not a plus 2 or minus 5 or anything out here outside of that base and exponent. So again, the asymptote was at y equals 0. Versus this example, I have that -1. So because of this value, it has shifted down, and now that asymptote is at y equals -1. It will never cross -1 for y values. Alright, let's look at this next example. F of x equals 3 to the -x plus 1. So I'm looking at that and I'm saying, well, what would I put in here to make this exponent 0? Well, if I put a 1, it'd be -1 plus 1. So that's where I'm going to start. I'm going to put that in the middle here. I'm going to put just a 1. And then I'll go down. So 0, -1, and I'll go up 2, 3. So f of -1 equals 3. So -x, x is -1 plus 1. But a negative is a positive. So that's really +1 plus 1, which will be 3 squared. And 3 squared is 9. So that one's tricky because all the negatives. We had a -x, we plugged in -1, and those two negatives made a +1, plus the one we had up here already. Okay, now let's do f of 0. So it'll be 0 plus 1, which is just 3 to the first power, or 3. F of 1 would be 3 to the -1 plus 1, which would be 3 to the 0. Anything to the 0 power is 1. And then f of 2, so 3 to the -2 plus 1 will be 3 to the -1, which takes the reciprocal, and we get 1/3. And then lastly here, f of 3 equals 3 to the -3 plus 1, which will be 3 to the -2, which is 1 over 3 squared because of that negative exponent, which makes it 1/9. Alright, let's plot these points. We had -1, +9, 0, 3, 1, 1, 2, 1/3, and 3, 1/9. Alright, so let's talk about how low this graph is going to go, the range here, is it going to go below the x-axis? What do you think? Were we adding or subtracting anything out here? The answer is no. So the asymptote is going to be at y equals 0. So it's never going to go below the x-axis. And so if I connect these, it's going this way, coming down, getting closer and closer, but never crossing the x-axis. Now that's going to be a big thing for me. If you know how low or the range of this graph, okay? So pay attention to these values here. I don't want to see it go below that line or go below this line. Now, before I said if the base was a whole number, it should be going up from left to right. But because of this negative here, we had a negative x, it actually flipped it across the axis, the x or the y-axis. So it's a mirror image of what it would be if it was a whole number. And then this +1 here has shifted it 1 to the right. So again, you might say, but wait a minute, you said it was going to be the opposite sign of what was in here. But again, that negative x throws everything off. So essentially, it's going to shift wherever this value would add up to 0. So what I mean by that is set it equal to 0. So if I subtract 1 from both sides, I get negative x equals -1. But then I have to divide by -1 to get that alone. So x equals 1. So it shifted in the positive 1 direction. Versus up here, if we set that equal to 0, we would subtract 3, and that's it. And that's why it shifted -3. And here it shifted +1 because of this negative. So essentially, take whatever this is, set it equal to 0, and that's usually where I start on my picking my points, and then I go down and go up from there. And also, that is going to be how far it's going to shift, right or left. All right, and there you go. So to sum it up, I would start with whatever your exponent is, make it equal to 0, and that's the value I would start with. Pick some values below it, pick some values above it, plug them in, evaluate to get your y values, plot them, connect the points, and always think about how low or the range of that graph. So again, the range of this one would be, it's going to start close to 0, but then go up forever. But I'm not going to include 0 because it's never going to touch that x-axis. So that's the range. The domain is everything. It's going to go left and right forever. So remember, domain is how far left and right. Range is how far up and down. Versus this graph, the domain is still everything. It's going to go left and right forever. But the range, it's now going to get close to -1, but never touch it, and go up forever. Alright, so those are some key points for graphing exponential functions.